Thank you for making out on the morning of the second day. I know how rough that can be plenty of times. So the plus side is if this talk totally sucks, you can, since it's 11 a.m., you can just leave and get a long lunch and actually enjoy yourselves. So you win either way. Cool. All right. So let's jump into it. So my background, 30 seconds here. I started out as a pen tester at ISEC Partners, which later became NCC Group. I moved over to Etsy to become their first CISO. They made me an offer I couldn't refuse to kind of put my money where my mouth was from writing a bunch of pen test reports. And amusingly enough, I actually wrote a bunch of their pen test reports, and then they're like, all right, sucker, come fix them. And for some reason, I fell for that. So went over to Etsy and became their first CISO and built and ran the security program. And then flash forward a number of years, we kind of took those lessons learned about how do you defend applications that are going through this jump to DevOps and cloud. We turned it into a product that became Signal Sciences. So the only vendor thing that I will say in this entire talk is if you're going through the shift to DevOps, you're going through the shift to cloud. We were so fed up with vendors not actually solving our problems and helping us there that we became a vendor ourselves to actually make something that helps out. So no one wants to hear from a vendor, myself included, so we're not going to talk about that. We're going to move on to what this talk is actually about, which is what are the lessons learned as you're going through this shift to DevOps, to cloud, to Agile, to CI/CD, to whatever we want to call it. So I will give you the spoiler up front, which is that security fundamentally shifts from being this kind of outsourced gatekeeper to focusing on enabling teams to be secure by default. If you paid me, I don't think I could have written a more cliche sounding sentence than that. However, it doesn't make it untrue, right? I dare you to try to distill it down into one sentence. This is about where you end up. But this is a really fundamental shift for security. I'm going to go into how this actually changes our security programs and what our lessons learned were. I mean, really at the end of the day, this talk was the talk that I wish I could have given myself on day one of a shift to DevOps and cloud. Instead, I had to learn a lot of incredibly painful lessons because at the time it was Netflix on the West Coast and Etsy on the East Coast that were really the ones inventing what became DevOps. So, what has changed? There's kind of three things here. The first is that change happens not just in order, but orders of magnitude quicker than it used to. How many, I promise I won't do the like show of hands things that many times, but how many folks have actually worked in like a waterfall shop? Yeah, okay, we can all drink afterwards and share horrible stories. But what that was like was, deployments would happen on the order of months to years. This was made super apparent to me where my last project at ISEC Partners was doing a pen test for a US healthcare company where they deployed every 18 months. And I left there on a Friday. I started at Etsy on a Monday because I took no time off because I'm an idiot. And I walk in on the first day of Etsy and they're like, cool, we deploy to production 20 times a day. Figure it out. I'm like, okay, step one, buy the biggest bottle of whiskey that you can buy. Step two is that will be gone by 10 a.m., so buy another. And then start to figure it out. So, I mean, deployments, they would go from that amount of time, and what we're trending to, I'm not saying everyone's going to 20 times a day. I mean, by the time I left, Etsy's doing 100 plus a day. Not every organization is going to that. What every organization is seeing is that they are on this journey to DevOps and on this journey to cloud. And for some organizations, that might end up meaning deploying once a month. For some, it might mean once a week. For some, it might mean once a day. For others, it might mean 100 times a day eventually. But no matter what the actual number ends up being, this shift profoundly changes the way that we think about defending apps. And then the second key piece is that this decentralized ownership of deployment, right? You used to go through this like Oregon Trail like journey from dev to QA to staging to security back to dev to something, and like code would get cholera crossing a river on the way to QA or something like that and reset everything. And now it's really, the whole point is that your development team can ship code directly to production. Actually, how many folks in the room are developers for like full-time? Awesome. And how many are the rest security folks? Is that awesome? Okay. I love the balance, by the way. That's fantastic. So as development teams and DevOps teams kind of own the means of production, no pun intended, to deploy code straight through, it changes two things from security. It changes the way our technical controls work, which is what this talk is about, and then it also changes the way that our security programs kind of have to operate culturally. So that's what that link at the bottom is kind of the other side of this coin. I realize now that I'm standing on stage that the deck is actually the outdated version. So if you want an updated version, you can just email me. I'll send you the other updated deck as well as this one. So the kind of third and final point here of this is that the existential shift that we are actually facing in security right now is that security can no longer be outsourced to and kind of thrown over the fence to. Security's number one role now is focusing on making teams security self-sufficient because it's the only way we scale. It's the only way we actually enable this shift to DevOps and cloud. Right? Is there anyone in here who has enough security people? Right? Like we're all stuck like with 50 open headcount, and at the same time, the organization is moving faster and faster and faster. The only way we win and the only way we scale is by making these teams security self-sufficient. And it only becomes successful if it can actually bake into the development and the DevOps process. We're kind of at this existential shift point in the same way that kind of IT or server procurement teams were about 5-7 years ago, which is that an app team would come to them and say, hey, we're working on this new app. We need a couple new servers in the rack. And they'd say, cool, that will be live in 11 months. And they're like, haha, no, it won't. I've got a credit card. It will be live in 5 minutes because there's AWS. Security is at the same point right now, which is if we say, okay, before you can ship that code to production, it's going to go through a 3-month review. And they're like, yeah, it's cool. You guys do that. P.S. It's live. So security has to fundamentally change. First, I will give you a highly technical diagram of how it worked for us when we tried to not change and just use kind of the legacy ways that we've done AppSec controls. You saw the security train plow into the development car while shouting about safety at the same time. So it's got to be one of my favorite memes, honestly. It's perfect. So what are the actual pieces of the SDLC, right? The details of this are going to be different for every organization, and not every organization follows every piece of this. But if you look at a macro sense, what does an SDLC actually look like across most organizations? It's mostly these pieces, right? Some bit of training, some threat modeling, down through some pen testing and feedback. So which of these actually need to adapt the most when you're going through this shift? That's going to be this is the agenda for today. So I want to be very clear, and this is why I put the note on here. I am not saying those other pieces do not change, right? Training changes, design reviews change, threat modeling changes. I've got a 50-minute time slot, so got to cut things down. Getting started on the lunch, good call. But these are the ones that I promise I won't call everybody out who leaves. Don't worry, you don't need to be worried. But this is what we're going to talk about today, is kind of how have we used these in the past and how do they adapt the most. All right, first up is static analysis. When I did a kind of preview private version of this talk for some friends, someone told me that their record was an 11,000 page static analysis report when they first turned on Fortify one time. I'm curious if anyone has beaten 11,000 pages. I know it's got to be. Yes, thank you. Go in once, go in twice. Yeah, static analysis. It's a party. So how have we done it in the past? And this is going to be how I'm going to run through these sections, is how have we done it in the past? And then how can we adapt these controls? So in the past, it's really been done as a very heavyweight process, right? We brought in typically like a heavyweight commercial static analysis tool. We turn that on across our code base. We'd get 11,000 or plus pages of false positives, and then we'd spend a ton of time tuning that down and eventually saying, okay, well, we feel decent about this portion or anything there. The interesting thing is that this was actually acceptable-ish in a waterfall world. Because if you think about it, if you're releasing every 18 months and it takes you 16 months to tune a static analysis system, well, you missed one release. So like it kind of worked in the model that we were operating under at the time. So how do we actually adapt this? So I'm going to give you 3 things for static analysis. One is how do we change the core static analysis, and then the next 2 are kind of clever things that we had to learn along the way that are ways you can turn the problem on its head and get some really interesting results out of. So for the fundamental static analysis, the biggest lesson learned there is you start from bottoms up. You don't turn on from kind of top down. I'm going to give you the methodology. I'm going to give you a specific example next. But you don't start top down with everything. You turn on from one vulnerability class, and you work on that, and you cut the false positives on that. Then you add a second. Then you add a third. And at the same time that you're going broad across vuln classes, that's when you can also start to go deeper with them, right? You can start with things like grep at the most basic level for one vulnerability class and move up from there. Because what you have to actually solve during this is a 50% a technical problem. This is 50% a cultural problem at the same time, which is that static analysis has been an incredibly slow process for most organizations. So when you have development teams, or you are a development team, and you're going towards, agile, DevOps, anything like that, the only perception you have of static analysis is that it's incredibly slow. It's that thing you run once a month on a build server and get a report, 8 days later. What you want to get to is showing that static analysis can be a really effective control that actually, if you kind of invest in this, you can get to run on every code commit. That's the goal you've got to be going towards, is that for any of these security controls, they have to actually enable velocity. So the practical example on that is, rather than just starting for everything, pick the vuln classes that are the easiest from a static analysis point of view to go detect. Tried a bunch of them. The ones that I've seen as kind of the commonality amongst organizations is command execution, because for any technology stack, there's a half dozen ways to, introduce command execution vulns. So you can start, and I say it halfway sarcastically in the slides, but halfway true as well, which is that grepping for system is a low false positive rate. It's kind of true, right? If you grep for, if there's half a dozen ways to introduce command execution, you can grep for those, and then you can start to build kind of data flow analysis on top of that and build up from there. But the point is, the focus is not only on findings, it's also on demonstrating to the development organization that this is something that can actually bring both value and speed, right? And velocity. Okay, so the two other ways that we can turn static analysis on its head. One is, how do we use it as a way to identify what can actually drive conversation across the organization? So how we used to do this is kind of turning the policy use of static analysis on its head, which is we used to, and today still, write policies for static analysis saying, hey, MD5 is banned. We want to use a modern hashing algorithm, a SHA-256 or something like that. SHA-1 is banned as well. And so you'd implement that in static analysis, and you'd say, oh, you tried to check in code with MD5, that's blocked, use SHA-256. The problem is that the failure mode there is silent, in the sense that why is that actually being introduced in the code base? That's the more interesting question. Swapping MD5 for a SHA-256, that's straightforward. That doesn't matter. What matters is, why is that actually being introduced? So using static analysis to say, for certain primitives like hashing or encryption or file system operations or anything like that, things that are naturally high risk, use those as red flags to say, this should drive a conversation with that team. It doesn't have to be with security. It can be with security. It can also be with, a lead architect, a DevOps lead, something like that, that says, hey, when this is showing up in the code base, there's inherently something special about it, so let's use that to drive a conversation. Like many things in this talk, sounds very dumb at first. This saved us so many times it was ridiculous. Where we would go, it would show up in a new, like with a new team, a hashing function would show up. And we'd go and talk to the team and say, hey, we noticed you're using hashing. Like, what are you trying to do? And they're like, oh, well, we're going to collect this whole new set of user data in this new way, and we want to protect it. I'm like, okay, cool. And they're like, okay, so we're going to hash it. I'm like, oh, okay. Hashing is not actually what you're looking for at all here. And actually, we built a whole kind of key management service internally that's going to handle all this for you. So all you have to do is one API call to that, and you're all set. And like, oh, awesome, because we didn't know where to store the keys or anything like that. It can drive really fruitful conversations across your organization. And again, this isn't something that you're blocking on right away. You can block for certain high risk ones, but for others you can just say, hey, this should toss into the queue for a conversation within a SLA that you set, a week or a month or whatever, depending on the severity. The final one for static analysis is proactive alerting for when sensitive portions of the code base specifically have changed. So sounds a little bit similar to the previous one, but it's rather than like a hashing function being introduced. For any application out there, there's always the parts of the app that are kind of write once, update never, that are written at the beginning, like the role-based access control bit, or a custom encryption wrapper, or your session management, right? The things that are written at the very beginning of the app and then they're never changed. What you want to know is if they actually change. Because what you can do two things. The first thing you can try is you just block on those changes pending a review. Do not do that, because the moment that you have, I say that from experience, the moment that you have an outage at 3 a.m. And someone needs to change that and security just block that change pending a review while there's a massive operational issue, you are not going to have a fun day the next day. So what you want to do, what can actually be really effective on this, is you say, okay, whenever certain sensitive portions of the code base have changed, what you say is when that code is being introduced, whatever source control technology you use, regardless of that, you say to the person committing the code, this is going to alert these 5 people across the organization. It's going to alert like the CTO and the chief architect and the CISO and stuff like that. What that gives you coverage over is the intern who just made a change to the wrong file is going to back that change out incredibly quickly because they didn't realize what they were doing. But the SREs that are in the room triaging an issue at 3 a.m., they're like, yeah, go ahead and page them. They're all in the room with me right now. Like, you can enable velocity with this without sacrificing coverage. And that's the real key. Okay, so moving on to dynamic scanning. This meme has no relation to dynamic scanning. I spent an embarrassingly hours trying to find a dynamic scanning meme. If you can find a dynamic scanning meme, you are a better speaker than I am, and you can just come up and take it. It's like King Arthur with the sword in the stone. Just, you are the speaker now. Congratulations. So dynamic scanning, pretty quick. We used to use it for vulnerability discovery, right? We would scan our apps and we'd say, hey, if a scanner found it, we should probably fix that, right? And a scanner being like a app scan or something like that. And occasionally misused as a substitute for pen testing. But for the most part, it was kind of used in this same way. So how do we actually adapt this? This is the one that I think changes the most radically, which is that I'm not saying that scanners cannot be useful. In fact, I'm going to give you 2 super cheap and effective ways to use them. But the way that we've used them in the past, applications have fundamentally changed. If you look at an app that was built 10 years ago, 15 years ago, whatever, they were very linear, right? It was page 1, page 2, page 3, through a flow. You could kind of crawl that and test a bunch of form fields and everything there. You look at a modern application, and it's a ton of client-side functionality. It might be a single-page app, might be totally API-driven as a mobile app or something like that. Typically what I've seen across organizations is that the technology behind the scanners has not actually changed into this modern world. And so I'm not saying they're useless. I'm saying that we all have so many projects to do that they're typically not worth the bang for the buck if you have to invest so much time to actually get them to interact with the modern app correctly that it's usually better spent elsewhere. But there's 2 really cheap and effective ways that you can kind of turn the problem on its head there. The first is actually ensuring that your security policies are being enforced, right? So one of the security policies that a bunch of us have worked towards and rolled out is for all of our applications, they have to be over TLS. Great. We've mandated that. We flipped the big config setting on our routers or on our Apache configs or Nginx configs or whatever. But just like anything else, there is a lot of edge cases that happen, right? Production is messy. And so scanners can actually be really effective to continuously crawl your sites and say, it's real simple, stay within this domain and alert me if you ever find an HTTP link. That simple. And they can be continuously going. At the same time, you can also look for other security policies, like the HTTP headers that you would use for security, like X-frame options or content security policy or things like that. Same exact approach. Excuse me. Be crawling continuously and alert if you ever see a response that's either plaintext HTTP or does not contain these security policies or anything like that. That was not actually a dramatic pause point. My throat is just crazy from being in the desert for too many days. And then the second is as an extra control on vulnerabilities being reintroduced into the code base. So I'll give you an example of this is say you have an XSS in the search box, right? Your most kind of typical vulnerability for a web app. And you discover that, and you fix it, and then you write a unit test for that fix, and you say, okay, all good. Again, that works great in theory. Practice, as everyone in this room knows, is very different than theory. And so I can't tell you the number of times doing something like this saved us, where it's pointing a scanner at a known vulnerability that says, listen, every hour, just try to throw an XSS into this search box and alert if it ever actually succeeds. Because you get really good coverage over two things then. One, a vuln was reintroduced into the code base for some reason. And two, that unit test is not working, clearly. So you get a nice kind of fallback coverage over a number of things there. All right. Moving on to security visibility. This is a sarcastic Twitter feed that hits way too close to home way too many times. It's painfully accurate a bunch, and this is one of them. So how have we had security visibility in the past? It's pretty simple. We basically haven't. We've had a bunch of siloed bits of data. Logs over here that maybe just our sysops group had access to. Customer service reports saying, hey, we're getting a bunch of errors about our SSL cert or something like that. Outages, or what people think were outages that the development team started working on or the DevOps team started working on. Each bit of information was really siloed across the organization. So how do we change this? The good thing is, we are relearning the same lesson right now that DevOps had to learn 5 years ago, which is that the way that this shift to DevOps, and then if you DevSecOps or SecDevOps or whatever we want to call it, the way that it's actually successful is by bringing these different sets of data together so that everyone has the context that they need and the visibility that they need. It's, again, cliche alert about breaking down silos and all that, but it's actually true, right? Like, these were siloed bits of data, and the way that it actually becomes effective is you bring that data together. So I'll give you an example, which is take 500 errors in an application. What's interesting is if you ask different parts of your organization what this implies, you will get wildly different answers. So if you ask your development team what this means, they're like, oh, we had a brand new junior developer, that was their first code deployment, and actually it all went sideways and we backed out the change. If you ask your DevOps team what that means, like that's the third time that team has paged me this week and I might murder them. If you ask your security team what that means, is that somebody discovering a vulnerability, right, at the kind of the start of the vuln chain where they're, or the attack chain, excuse me, start of the attack chain where they're discovering a vuln and trying to trigger errors in the app and then start to figure out a payload. And then if you get to, you go ask your attacker or your pen tester or your bug bounty participant and they say, oh yeah, that was actually me discovering a vulnerability right now. So the key is you start to think about how do you bring together security relevant data with operationally relevant data, development relevant data, so that every group can look at this and have the context and say, oh, that thing that we thought was a bad deploy, actually, that's at the same time that somebody's attacking us. That may have not have been a bad deploy. Actually, we need to see what's going on here. And the key is that everyone can self-serve out of this data and out of this visibility. All right, getting near the end. Feedback. Okay, side note, Office Space is 19 years old now, which makes me feel incredibly old. And B, I think technically qualifies this as a vintage meme, so I don't feel bad putting an Office Space meme in a slide deck in 2017 anymore. Okay, aside over. Feedback is typically been done as annual pen tests, right? How many folks do annual pen tests? Cool, yeah. I mean, and the challenge is it ultimately only answers the question, do I have bugs? Right? And the answer is yes. Everyone has bugs. That's software development. It's how it works. But kind of like static analysis, when you're only releasing every 18 months and you do an annual pen test, it was kind of good enough. So how do we actually adapt this? And this is really where I think bug bounties come into play. And I say this as somebody who's been on every side of this in the past, which is that why I really like bug bounties is that they are so complementary to pen tests that their strengths are pen test weakness and pen test strengths are bounties weaknesses sometimes. All of this is a little bit fuzzy, right? But it's that the most important point I'd say is that bounty is not a replacement for pen test. Where when you do that annual pen test, right, the dirty secret is, it's typically a 2-week engagement or something like that, and you're stuck with the same choice that all of us are stuck with, which is that, do I ask my pen test team to go try to cover everything and give me kind of a shallow layer over that, or do I ask them to focus on this one particular thing and go deep on that and then ignore coverage everywhere else? And there's no magic trade-off other than infinite budget. So I think where Bounty is really good is in the kind of continuous nature of it, and typically it gives more breadth for the most part. Then what that frees you up to do is take your pen tests and use those to focus on the most problematic areas, or the stuff that is super pre-release and you need to NDA people up about it, or wherever you want someone to focus and do a deep dive on the application or the code or anything like that. And so the two coming together complementary, it's really fantastic. It gives you the strength of both. Now, I'm not saying, launch a Bounty today, this afternoon while you're here or something like that. There's a lot that you want to think through and go through. There's a bunch of good companies now like HackerOne and BugCrowd and all sorts of good folks, that handle the logistics for you, which is by far the most painful bit. I mean, back in the day, none of those existed when we YOLO'd and launched ours. And yeah, that was 2 weeks of my life I will never get back. But they are much easier to actually launch now and can really be thought about it as complementary in terms of feedback. All right. A ton of security speakers take themselves incredibly seriously and want to give you about a bunch of thought leadership. I will instead leave you with thought leader Hosen, which if you think that joke was bad, I did it in Germany and holy crap. That was stoic. Yeah, fun times. Okay, so here's some thoughts on where I see modern organizations that are doing this the best. What's the commonality amongst them? So the first is that the hallmark of the modern application defense, and actually defending your applications in this shift, is the combination of continuous feedback and continuous visibility. That's the hallmark of it. The way to think about it from the attack-driven defense side is, if you want to be successful against real attackers, you need to be able to answer the question, how do I know when my attackers themselves are being successful? And for the most part, we can't answer this question, especially at the application level. So as you start to move down this, you really recognize that there are 3 incredibly great opportunities for really strategic benefits out of this. I mean, this is probably the point where I should say, when I started on that day 1 at Etsy and they're like 20 deploys a day, I'm like, this is pointless. Like, this can't be secured. Like, this is going to make things so much worse. What I came out the other side actually believing is that this is actually the shift to DevOps and cloud, if done right, is our opportunity to actually be it's a net positive on security, if done right. And the reason is, for the first time, we have the ability to move faster than our attackers. That's crazy. I'll go into that in a second. But the first part is, you want the ability to detect your attackers as early as possible in the attack chain, right? Attackers have a set of, kind of a loose set of structure that they follow, right? You have to go do vulnerability discovery, and then exploitation, and then land on there and do lateral movement, and then C2, and then eventually exfiltration, and just like the SDLC. From a high enough level, the steps are somewhat similar, but every attack is a little bit different. You want to be working backwards from that, where right now, our alerting mode for the most part is your cell phone starts ringing and it's Brian Krebs and he's asking for comment about your database being up on Pastebin. That is not a good alerting point, and we want to be obviously better at that. So working back from the end of the attack chain and saying, okay, from an exfiltration point of view, how would we have visibility into that? How would we actually make that more difficult for attackers? Back to command and control, back to lateral movement, back to up through initial reconnaissance and vulnerability discovery. But you want visibility at every point, and you want to make it more difficult for attackers at every point. The second, and this is the real opportunity that I was talking about a second ago, which is that for the first time we can move faster than our attackers, because as you're going, if you think about it from a positive lens, if we're deploying 20 times a day, or even 1 week, right, compared to every 18 months, it means when that critical issue is found, it can be just another deploy. How many of the waterfall folks, how many have lived through like an emergency patch as part of a waterfall cycle? Yeah. It is a nightmare. If you release every 18 months and there is that critical, SQL injection found on the front page, and you just released 3 months ago and you're in the middle of the cycle, good luck. Because what that's actually going to look like is 2 months of pandemonium of trying to get the release out the door. It's going to release, it's going to break a whole bunch of other things. It's a total, anyone who raised their hand, buy them a drink and ask them for the story because it is going to be crazy. So what's nice here is that because we can actually move faster, when issues are discovered, inevitably, we can actually react. That's the real key. And so with this kind of model, when issues come in, whether it's from a bounty, whether it's from a pen test, whether it's even just a issue that's discovered even by someone internally, you can start to use these as benign test cases to test your triage and response. So you can say, hey, the first time a bounty issue comes in for some, I can tell you this from experience, a bounty issue will come in and or a pen test issue will come in and you're like, wait, what is that? Not what is the vuln, what is that app that the vuln is in, or the infrastructure that vuln is in? I didn't even know that we had that. And so you can start to use that to test your triage and response and say, okay, if this had been a real attack, right? If this had been a legitimate attacker who was exploiting this right now, who would we go talk to? How would we triage this? What would our process actually be? And so it's great because you get to run this triage and response in a controlled environment here without all the fire alarms going off, so that when they do, you've got this. You're like, okay, it's another incident, it's another thing, we can push a fix, we can react here. The third and final one on these three is that it gives you the ability, it's kind of the other side of the coin of number 2, which is that it gives you the ability to continuously test and refine your DFIR, SecOps, incident response process, where what you do is when one of those comes in, treat it as a real issue and say, okay, you'll start to ask yourself a number of questions that you will really not like the answer to, which is you'll say, okay, this issue that just got reported, how do I know that they didn't discover something else that they're not telling me? How do I know that they didn't discover it themselves and use it for 6 months before actually telling me? How do I know when this was actually discovered and it was a great researcher and they reported it right away that it actually hasn't been exploited in the wild for the last year? How do we actually know any of this? And like I said, you're not going to like your answers when you're first honest enough to ask yourself those questions. And so what's great is you're able to take that and use that to start to say, okay, where should I then be investing in to be able to answer those questions, right? How do I get this visibility? How do I get it to these sort of teams? And how do I have this sort of coverage? Because I'll give you one of the scariest incidences I've ever had on the AppSec side with this, which was that we had a bunch of visibility in place. We'd invested a ton in there, and we got to the point where we saw somebody discover a vulnerability on the site. And this is in a past life. And we watched them discover it. It wasn't automated. They were clearly doing it by hand. They kind of tripped over a vuln, and then they started to do a bunch of payload refinement so that they could actually get a working exploit. They got a working exploit, and then they stopped, and they went away. And they didn't use it. They didn't report it. They didn't do anything with it. Like, okay, that is incredibly terrifying, because what are you actually stockpiling that for? Like, you think that you're going to get better use out of it later on? Like, okay, that is not a good day. Because we were able to detect that, we were actually able to fix it and everything there. But it wasn't because we were so smart or something like that. It's because we had asked ourselves a bunch of these questions and realized that we were totally blind to a bunch of this. And we started to really go about trying to solve those problems. So many security talks are doom and gloom and everything like that. So I want to leave you on a positive note, this was public, so I get to actually talk about it and everything there. This was a different case where one time at Etsy we actually had something where somebody discovered a vulnerability. They were at the vuln discovery bit, and they were still trying to kind of refine their payloads and everything there. And we detected it, and we pushed a fix that fixed the issue before they reported it or had a working exploit for it. It was awesome. It was one of the highlights of my AppSec career. And then the person ended up reaching out. They ended up doing a whole write-up. It's still up there on Reddit. You can read the whole thing. They ended up doing a really cool write-up, but they ended up reaching out and emailing us and saying, hey, so I noticed my vuln suddenly stopped working. I was testing from my home IP, and you're not going to sue me, right? And we're like, oh no, actually this is awesome. Check your Etsy account. We actually messaged you when you first started testing and just said, hi, we see you. Like, here's an email address if you find anything. And so, yeah, it was awesome. Yeah. Thank you. Yeah, it was Really, really good team over there. So this is what I want to leave you with, is that it's not some kind of, random edge case that can do this. This is where I see modern organizations headed to. As they're going, this shift to DevOps, this shift to Agile, the shift to cloud, all this, it gives us this nice clean slate where we can start to really think about how do we have the ability to move faster than our attackers for the first time? How do we get the coverage over that? So I'll wrap it up. Which is that the thesis of modern application defense, modern application security, we're shifting from this SDLC model where everything was focused on trying to eliminate bugs before production, which isn't wrong, by the way. That's not wrong. It's just an impossible goal, right? We're never going to get bugs to zero. So we don't stop doing that. We adjust it in the ways that I was talking about, and we really focus we take this as an opportunity as we're embracing DevOps and everything else to focus on how do we get continuous feedback, continuous visibility with our ultimate goal of making teams security self-sufficient. So you're awesome for sticking around. Thank you for having me.